let's see multiple linear regression. So previously I show you here that graph here. Just see, right? So like this is slope. Can you see here a no difference something here? The data points are not here. Okay. So same you can see here this graph. Try to understand once again. So this is the some predictor over here, right? This is our target value, and this is our slope, or the equation actually, right? And it should be show there should not be any difference between predicted value and actual value, because data is actually here. This is our predicted value. This value should be very close here, right? In that case, please have a look. There is not like a here data. So predicted value is here near the slope. Okay, so in that case, the residual variance and explained variance, there are two things, two portion, two part. Residual, that is a difference actually, and explain, that is a variation I told you. So residual should be low. Okay, and explained part should be high, right? So that's why I put it here, should be more. This part we need more, and this part we need less, right? So this is important in a multiple linear regression, or maybe in the linear regression as well as. But now let's see some theoretical part. It is just a extension of a linear regression, right? And one target variable and more than two independent variables. So sometimes we say regressor, right? And predictor. It is used to predict the target variable that is dependent variable. And obviously, I think I didn't mention here, both variable should be again metric, scale, or continuous, right? So to explain the strength of a power of a independent variables regressor to predict the target variable, right? It will not predict as well as it will. I told you two parts: difference residual predicting and the explanation part, right? So see how powerful this regression approach. So also reveal the correlation between, yes, I told you previously, it will also show the some correlation, and correlation we can see by the which value? Which value?
P value.
R value. R value. Which value? R value. Here. R value is 0.513. If you go into the model, because we are just looking in the model here, it is here in linear regression. Okay. So this is our R. Okay. So now also found a, it will also tell us whether my model is a significantly or not. It will tell in the linear regression previously, right? You saw. But in a real life, I don't want to care for a lot of variables or features, which is important. So maybe our boss or teacher will give us say 20 features, right? So maybe 20 features are not useful for me. I have to see which feature or which variable is good for me, good for my model, right? Okay, maybe 10, 5 or 6, or maybe 20 feature can be good. So it doesn't matter. So it will also help us for selecting the features. And remember, in a data science, selecting the feature is nothing. It is very simple. You have to see, they are significantly or not. And you know very well, you can easily compare with that p value, probability value, right? So it is important. Now, in a previously linear regression, we cannot do because we have only two values, two variables. But here we can have a thousands of a variable. Okay. So now sample size. Sample size standardized basically, actually in a book you can find, this is a desirable actually. Sometimes you can go for a 1 to 10 ratio. 1 to 10 ratio mean to say if you have a 20 variables, you have to need a 100 answers, right? So this is like a standardized, it is desirable. But in a real life we have a lot of data, so it is very interesting to analyze them. So it is very good idea. So this is, if your data is less than this one, so your regression will not give good results. Okay, because we cannot generalize or apply on the population, real population. So both variables should be metric or scale. One more important, we have to use a stepwise method. Stepwise will actually the method which will select your feature actually, right? based on some correlation value or something, right? So you please find that one. No need to use the enter method, right? And you have to use the stepwise method. Previously we use the enter method, we give all the variable to our model, but here we will give only selected model to the selected feature to our model. So in that case, stepwise method is very useful if you want to use. So theory is clear to you? Is it clear? Okay, so assumptions and some validation metrics I want to tell you, because please some definitions please read on the internet and see how it works, but I will put it here for your knowledge because it is a it will be take a long time, but it is important to discuss or take some practices. So assumption is a linearity. I show you previously in a linear regression, as well as constant variance, error term for each value, that is the residual, and independence term, Darwin-Watson test. I show you like a correlation. If you remember, normality of the error distributions, residual should be normal. So these are the again four type of a assumptions again here. Okay, and the equation. I'm giving the equation you here. Previously, we have only one target value. Yes, we know, but here we have a more than n predictors. Can you see here a plus b1 x1 plus b2 x2 b3 x2 and so on, right? So e is a like our residual error term. Okay, so y is a target, a is intercept or a coefficients, right? And b1 b2 is like your regression coefficient of a predictor, right? And x1 x2 are your regressor mean to say the variables. A is a difference between the predicted value and observed value, right? Or maybe observed or predicted value, right? So like e is a error term, residuals actually, right? So now two regressors should not highly correlated, right? Please remember, now we have a lot of variables, so we cannot go for each variable, right? So there should be some mechanism how we can check that two predictors are highly correlated or not. In that case, we have a variation inflection factor, VIF. Okay, and a tolerance you can use. Okay, so this is the important metric we can check highly correlated, or basically this is a multi-collinearity, right? You please find on the internet, you will see. Okay, so these are the some assumptions. Now validation metric. I put it here, validation metric. On which values on behalf I can say that my model is a perfect fit for apply. Multiple R, you see, I show you that is a correlation. R square value I show you, standard error you can also check, and ANOVA and F ratio. It will also discuss like analysis of variance, regression coefficient, which is important. We can make equations here, right? And standard error of coefficient. This is like a residual, right? You can also use it. And t value, why? It will tell us the difference in a mean, right? You can also use, because t value will help us to check the coefficient whether, because we have to calculate the coefficient for making my equation. Before putting that coefficient in equation, I want to check these coefficient are perfect or significant or not. So t will help us. It will tell me. So you will see how the t test is most important for a data scientist, right? So it is important. So correlation, partial correlation and part correlation, you please find on internet. This is not, this is like a basically correlation. There is a highly correlation, it's a pure correlation. Likewise, partial correlation mean to say medium type of correlation. This is important. Collinearity, I show you. Multi-collinearity means to say, I show you there should be more than two variable has a more than high correlation, and suppose one variable has the correlation with another variable, same variable has a correlation with another variable, so multi-correlated concept can be there. So we have to check tolerance and vi factor. So we have to give these matrices. Let's see the case study. The same case study I want to considering here, because it is a good data set we can use. So here I think you got the again case study, nothing to explain the data set again. The identify satisfaction score about publishing company, just here. But right now I'm not talking about only one data or one variable. we will talk about the overall general scenario, right? So like the quality services of the publishing company, you can write anything as you want, and based on these uh, you know uh, predictor or the features or variable, any term you can give in your mind, right? So it is not important. Now let's go for apply the multiple linear regression. Okay, so I think it is maybe I can use here again. Please be ready with me and analysis. And first step is again a regression. Regression is linear. Now here, take it to back. And what we have to do, take all the variables, send into your program, right? I think 14 variable, 15 is the target variable. And here I put it, select a stepwise method, right? This is a first step. Second is given all the variables to the feature, select a stepwise method. And third is the, again, some statistics. It is already there. Multicollinearity, I show you, please put it here, right? Okay. And plots, I think it is okay. We can use it. If you want to make a graph for each variable, go for a next and use it. I think it is done. And save. Okay, so it will create again two variable, unstandardized predicted value and residual. Okay, you want to check, and okay. So now the system will generate some model for us, and I think it is done. Please check it. Now, please test the assumptions. I show you the assumptions previously. So almost the same. You can use it. It is not important. And maybe in our graph, I can check these assumptions very well. I already checked it. So I think there is nothing to do. And here, we should focus on our results. Multiple linear regression output. Okay, so let's see. I want to go for here once again. Okay, so this regression is not important because it was our linear regression. It is our multiple regression, linear and multiple, the same data set, right? So descriptive statics for all the variables you can find, mean value, deviation value, or observations. Correlation value, you please see this is a correlation value. You can easily find which variable is correlated with the target variable, how, and with each other as well as, right? Have a look. This feature has a positive correlation like this with the target variable, right? If you want to check this feature with the another feature, you can see 0.022. So sometimes it has a negative correlation. Can you see if you it is a minus show, it mean to say minus negative correlation. So please, you can see all the correlation things here in all the data set here, right? But it is not important here for us. Important is to be model. Just directly go for the model. Now variable enter and remove. This table is also a good. It will check based on this criteria that f value, basically this is ANOVA value, analysis of variance, the probability should be is greater than or equal to 0.11. So basically this out based on this feature mean to say we need a significant features only, right? So this variable, can you see variable number 4, variable number 7, variable number 3, 6, and 1 and 10. So basically these are the basically variable which filter out by the 14 variable. So 6 variables found a perfectly, which is perfectly significant to identify the satisfaction score, right? So in that case, we have to use this table as well as you can use it, right? Now model summary, which is important. So please have a look. I put the model summary. We have to explain this model, which is important. So please R is a correlation. If you make a square this value, you can found the R square. R square is a explanatory power. Okay, so adjusted R square for the generalization concept, right? So it will tell the regressor to explain well, right? So please have a look. This R square value is increasing here. If can you see how many model I have right now? 6 model. Model number 1, model number 2, model number 3. So it is your choice which model you want to use. If you want to use a model number 1, right? It is a significant. So here I found all the models are significant, right? But it is your choice which variable you want to give to the audience or something, right? So here, please look R value. R value is increasing somewhere. It is not highly correlated. So it is 87% is again a considerable. Here it is closed, right? And adjusted R square is also again here. It is increasing. So every value is increasing, and after that, I am sure this value will be decrease, right? So please see, adjusted R square value is the value which we'll use for apply on the general population, and it will give that value that of this is the limit actually. After then, there is no variable for fitting in the model, right? Okay, so that's why we have to use this table or value here in this multiple degree regression. Okay, and the most important is see the significant. So I can say these all models are very perfect. Model number one, model number two, model number five. If you want to use a six variable together, please give this model, right? Okay, and Durbin-Watson test is also a good. It can be desirable. The value is in between 1 to 3. So it is also good. So please have a look of some equations which I took from the internet. I put it here. You please see how you can calculate it something, right? So it is there. Check it. Is it clear to everyone, I think? So let's go. I think next is my table is ANOVA table here. Again, ANOVA table is the most important table once again, which will tell us that about the only error term. Error term mean to say residual and regression. Regression is your predicted value, and residual is like the error term actually, right? So difference. So please have a look, which is important in this case. Previously, it was not important in a linear regression. But if you have more variables, please use this table. Have a look in the starting. If I use the first variable, what is the residual value? 111. Okay, next time I put another model, another variable in my model. What is the residual? It is going lower, right? It is decreasing. So it is as a data analyst, it is your duty to reduce this value, right? Now 85, 44, 42, and in the last 38. So based on this data, based on this feature, we found this is the value which is we can reduce up to now. So if you can reduce it up to 30, 20, 10 perfectly, you are very near to your good results, right? So if we have a six variable features, it can be that, right? So obviously we have to again give given our results, it is a again a significant. So all six model you can easily use for the research purpose or for the real time practices. So is it clear to you guys? Have a look. I put it in the bold faces. Explained variances here again. This is explanation power, and this is a residual here. Explain power should be high. This should be low, right? So it should be high. It should be low. Okay. So this is the unexplained part.
May I ask you, this residual part is a loss function?
You can say this is like a loss functions, but it is not exactly like a loss functions, right? So this is the actually you see the unexplained part which we left, which we didn't achieve. Maybe you can consider with a loss function, but it is not a loss function because loss functions has a different properties. So Mehdi, is it clear?
Yeah, yeah, yeah.
So please have a look. One more thing here which I want to show you. Coefficient. One more thing. There is another table I think here. I want to show you here. Coefficient important. So now the time is to come to create your own equation, right? Which is important. The same way which we use in the linear regression. Same you can use coefficients over here for your predictor. Predictor mean to say regressor or maybe feature, whatever you can say. It is not a important now. Okay, so please use that coefficients for your model. So here we are just focusing on this model because we have a six feature and we can use six features as well as. So these are the constant term over here, and here you can see constant mean to say we this is the value we are controlling others variables because we have a 14 variable, right? So for six significant variables we have a different constant value, and this value for which we left, right? So this is important. So please note that in your paper or maybe in your model, in your writing, this is important. We calculated it. Okay. So, and here, please have a look. Again, it is a significant value. You can calculate it. Again, coefficient B1 is a correlation. Again, I told you last time. And one more important, I took that snapshot for your help. And in on which base I should tell the world that these coefficients are good for us, because you are giving your equation, right? You have to prove that these numbers which you calculated or which system calculated for us, right, it is a good or not based on t statistics. So that's why we learned a t test in the starting. Do you remember? So t test is here. So significant, we have to go for there, right? And apart from it, there is a multi-collinearity matrices VIF and tolerance value, right? I will tell you later on. Just see, go for our sixth number of model here. Okay, so I found these variables are significant somewhere. Remember, one more thing, it is your choice. If this is a significant, please use that coefficient. If it is not a significant, you don't use, right? In this example, have a look. uh, Only this fourth number feature i found I found a t statics this value, right? And the value is less than 0.05. I can say I can use the model number 4, right, by putting this constant coefficients in my equations, right? So it is important to know. And how we can calculate t-test? You can use with you can divide with this value and you can find the t value easily here. So in this t value, we have, there is a log table. Okay, but SPSS give automatically the p value. So if you go by the manually, there is a table. You can compare this value with the log table, right? Then you can see that is the less than, right? So if you do by the manually, you can go. Otherwise, for system, it gives the automatically. So adding on significant variables cause a reduce the error term or residuals. That's all. Okay, now multiple regression output.
So it
Again,
should also be like less than 0.05,
yes, you're
and
right.
for that to be used. Okay.
Yes, coefficients, right? Because previously we found the only features, right? But now we calculated the numbers. Numbers mean to say the coefficients for each regressor. Example, why we this coefficient helping us? Because this is the value generated by the system and you are giving this value. Whenever the user will give the entry any number, because so suppose user can fill 40. So 40 will be multiply that coefficient, right? Okay. So again, another variable. For another variable, user will give another value. It should be multiplied with the second variable coefficient. All that will be summed up. After sum up, there will be a one target value. That will be your prediction value. That's why coefficient is important, because you have to multiply this number with the user given value. Okay, now next is the VIF. Okay, so the formula, it should be, if the t value is uh, above zero point 0.1, right? So there is no multicollinearity. Basically, it should be near to the one value. Actually, I should say it should be close to one. Okay, so can you see here, zero point 0.9 and zero point 0.9? These are the some variables. Just I in a list I have a different with six. Obviously, six variables should have a good tolerance value, right? So we there is a formula VIF. If you do reciprocal like 1 by t, you can found a VIFF, right? So this is the important. So you also state your result that there is a no multicollinearity, right? So with that result, with that value, then you can use it. Okay, so again, residual is also there. Durbin-Watson test will tell us the automatic relations refer to the correlation between the value of independent variables. While yes, I put it here for your references. Multicollinearity refer to the correlation between two or more independent variables, right? So it was basically the idea to use the multiple linear regression. In the last, based on this constant value, I just created a the equations. What will be the target value, predicted value? These are the some, x1, x2, x3 are the name of the features, right? And here you will see this is a prediction value and this is a residual value. So q15 is the target our value, which is in our data set in database, right? So 8.90 it was there, but this model given the value 7.8 with 6 feature only, right? So it mean to say it is a difference is very less, but your target, this is a residual, it should be very low. So please have a look. For that, you can see all the result. And in the last, you have to report your result like that. I used a multiple regression to identify satisfaction score, considering 6 customer variables or perceptions. And these variables, I found a significant, right? With F value 6 variable, 113 like the number of observations, because we have 120 and system remove some based on some outlier or maybe based on some missing value, they removed and 113 there. And this is the F score over here and p value. And one more thing, see the explanation power, r square. I told you this is explained part. So for data set, variance explained by 87%. Do you remember? So how multiple regression is more powerful as compared to the linear regression? Why? Because we have a different variables. Remember, in a real life, we will have a lot of data, we have a lot of variables. As much as we have a data, as much as we have a lot of variables, you can analysis in a good way. So I should say 87% good predicting power, I think say, right? So it is important.